Wow, look at that. That's my slides. I'm going to talk about scalability. I'm going to talk about NFT scalability. So I don't know if I have a clicker. Do I have a, is this, or do I just yell if I want some of my slides to go? Go. Yes. Okay. So this is the state of the world right now. All right. I think everybody knows this. As NFT awesomeness increases, gas affordability decreases, and we are in a state of NGMI. It's not great. It's not great. So what we're looking for here, just in general, is a state where as NFT awesomeness increases, gas affordability also increases. We go up and to the right, and then we will reach the state of WAGMI that we all desire. Right? Okay. This is just sort of trying to set the stage for like what we are all here to do, right? Which is like make this thing scalable and get this out to the broader community, to the billions of people that actually live on this planet and cannot afford to pay $400 gas fees and wouldn't if they could. So there's sort of a few basic ways to break down the scalability of a system, and I think it makes sense to sort of like think about this in terms of like the primary attributes that define what we're doing here and how we bring our products out to the world, right? So we have system throughput, which is just like how much the system can process. We have cost per transaction, which is basically like how much of that throughput is used in any given transaction. And then we have federation, which is like, can you scale this thing horizontally? Can you actually put it on different computers, get it out, and get to your web scale, if anybody remembers extra normal and web scale. And then on top of that, you have a bunch of things you can do to sort of try to like goose the engine a little bit, right? Put a richer mix in there. And so you can batch transactions where you can get some efficiency in setup and tear down by sort of taking a bunch of transactions that are the same, sticking them together, doing them all at the same time, more efficient. You can parallelize, which is not quite the same as federate, right? If you've done parallel programming, parallelization means you have a central queue of stuff you want to do, you split out work to a bunch of other workers, and then when they're done, you bring them back and you deal with integrating all of the answers. So it's not the same as federation because it has to come home. And then, this roll-up cost, which is this idea of like when you have side chains, how cheap can you make it to roll up side chain transactions and then put them back in the base chain? And how does that scale as you get to the sort of billions of users that we're trying to get to? So, my thesis here, and I think I've set this up like in a way that probably is pretty clear, but I believe that primary features dominate. That the first set of things is what really matters, is what will really get us there, and I think that the second slide of things is really a bunch of distractions fundamentally that are useful in the end. Like they're useful. They can add a little bit, but what's going to actually get us there is the first stuff. And really, what I sort of am here to shill is this concept of inter-blockchain communication that the Cosmos SDK allows, and that we're starting to see really do a lot of powerful stuff. As you've seen, Terra and Crypto.com and stuff, implementing all these things and becoming part of the Cosmos ecosystem, and having that ecosystem really exist in a way that's like usable. So what do we do like right now, right? Like what do we do right now to get ourselves out of this state of like $400 gas fees that we're in this week? So I think the simplest thing in terms of transaction cost is to move away from Turing completeness, which may not be the most popular strategy, but I think that Turing completeness is a really problematic way to go about doing stuff like NFTs. It's basically impossible to optimize because people can do whatever they want, and so what are you going to do, right? You can try to hotspot optimize it, but like you might fail. And even worse, you're subject to the halting problem, which if you've done a lot of computer science, you know about. But fundamentally, the halting problem is this concept in computer science that it is impossible to know whether a Turing-complete program will ever finish running. The only way to do it is to run it for the lifetime of the universe and see if it finishes running. There's no other solution. It's fundamentally impossible. So what do we do, right? What do these systems do? What does Ethereum do? What do all of the smart contracting Turing-complete systems do in order to deal with that, they've created this concept called gas, which is that you pay per cycle that you ask the computer to run. And then, if you run out of gas, the computer just drops your transaction on the floor, takes all your gas, and like goes home, right? Which is, first of all, like really inefficient because you're actually spending all of this time calculating how much time you're spending, which isn't great. And it really sucks as a user experience. Gas is really obnoxious. You have to have some, which if you're new to a protocol, you probably don't have any. And so your first experience with whatever new product is like going and buying something you don't actually want. I think that's a bad first experience. And yeah, it's unpredictable. Like you don't know how much it's gonna cost. There's sort of like, it's just generally bad. But unfortunately, it's pretty much the only thing you can do if you try to have a Turing complete permissionless system. So my proposal for step one for getting to scalability is move away from Turing completeness, move towards application-specific blockchain languages that do just the thing you want to do. That's one of the things that's so great about inter-blockchain communication is you can build a blockchain that just does the thing you want to do very fast, doesn't do anything else, no halting problem, and you can connect it to the broader world using inter-blockchain communication, which I think is great. And then in the long term, it is that inter-blockchain communication that is the big win. So federation is the answer. Federation is the way that the web got big. You know, you were never going to get the web to where it is if it was all just on AOL's computers. Like you have to have sovereign networks that can operate without needing to phone home to some like centralized, and I'm going to call the Ethereum blockchain centralized in this sense, right? You don't have to phone home to some centralized data system in order to carry on with what you do. You can just do what you do, and you can talk to the people you want to talk to. And this is partition tolerant, right? Like, if Ethereum goes down, does your app also go down? And if it does, why? Like, why should it? Shouldn't your app not go down if Ethereum goes down, right? I mean, you know, if you were built on Solana a month ago, like, your stuff went down, right? Why? Why did it need to go down? Like, you're not actually spending any SOL or anything if you're not spending any SOL in your app. So I think this is a really, really important, this is the big win. And this is what we should all be thinking about, is like, how do we get to truly federated blockchain systems? Inter-blockchain communication is one piece of that. It opens the door, right? It's because you can, in fact, federate with other systems. And I just want to suggest that we should be thinking about, well, okay, well then what is my thing that I'm really good at? What little thing can I do with my chain that I'm good at that nobody else is doing right now, that I can wire in to like the broader internet of blockchains and the broader Web3 experience that we're trying to meme into existence here? Let's see, I don't think that's, okay. So this is my little slide to talk about myself and my project. Fundamentally, Pylons is this federated, Turing incomplete, and fast chain for doing NFTs, for doing digital goods. And you know, this talk has really been sort of me letting you guys know like what are like the fundamental drivers that drove me to structure my blockchain in sort of a way that all it really does is just like digital goods transactions, and then you can connect to it to use those digital good transactions. And it does that without charging gas fees, and it does it very fast. And like those are the principles that, you know, that I've discussed that support doing that and that drove me to make those choices. You know, most of these I could go through this thing. I'm not going to, but you know, you see that Polygon there has the yes and parallelize, which is sort of the one side chain that I've put up here. I think it's really interesting, but I think that parallelization and trying to phone home again from all of your activities is fundamentally like problematic and unscalable. I just think as things get bigger, you wind up coming across problems that are just unpredictable. So that's it. This is the slide for questions. Over there in the right, you will see my email address. That's my name in the lower left, and I have 30 seconds, so if there's one person who wants to yell a question. Hi. I'm not on Ethereum. I've built using the Cosmos SDK, which means, so the Cosmos SDK is basically a layer 0. It allows you to build blockchains, and Pylons is a layer 1. Well, you can connect to those chains using various inter-blockchain the whole point is you can connect to Polkadot, you can connect to Ethereum, you can connect to Bitcoin. Yeah. Yeah, so the question is about token standards, and without Turing completeness, how do you sort of keep up? You know, I think those standards are a little too implementation specific. I'm a big fan of duck typing. I came out of the Ruby community, and I believe that like interfaces are the way that things should work. So RPC is you know what it's about. So it's about like RPC, and it's about encumbrances like royalties. Like how do you make sure those things work, right? And if you look at standards like DID, the distributed identifier, a lot of this stuff is there. Like, so you can implement these kinds of RPC standards in the abstract, and you don't need to keep up with the implementation details of sort of the Ethereum NFT standards in order to be able to say, okay, I want to call this method on this item. Okay, like I'm going to sell this and I need to pay you the royalty. The basic things that are necessary for interoperability are much simpler than what the standards actually empower. All right, I am 100 seconds over. Thank you, everyone.